Welcome back to Question with Answer. In this video, we bring you part 2 of the top Google Cloud Platform interview questions and answers, a must-watch if you're preparing for roles in cloud engineering, DevOps, or solution architecture at top MNCs. Let's dive into some more advanced and scenario-based GCP questions. Question 1. What are preemptible VMs in GCP and when would you use them? Answer. Preemptible VMs are short-lived, cost-effective virtual machines offered by GCP. They are up to 80% cheaper than regular instances but can be terminated by Google at any time if the resources are needed elsewhere. Preemptible VMs are ideal for workloads that are fault-tolerant and can handle interruptions, such as big data processing, batch jobs, and CI/CD pipelines. They have a maximum uptime of 24 hours and do not support live migration. These VMs help significantly reduce costs while scaling computation. Use them in clusters or when processing large datasets across multiple machines, especially when you can checkpoint or restart jobs. Question 2. What is Cloud Spanner, and how does it differ from other GCP databases? Answer. Cloud Spanner is a fully managed, horizontally scalable, and strongly consistent relational database service from GCP. Unlike traditional RDBMS, it supports global distribution with synchronous replication and SQL support. What makes Cloud Spanner unique is its combination of relational database structure, including ACID transactions, with NoSQL-style scalability. It is ideal for applications requiring high availability, global consistency, and scalability, like financial systems, gaming backends, or enterprise SaaS platforms. Unlike BigQuery, which is an analytics engine, or Firestore, which is a NoSQL document store, Spanner offers real-time transactional consistency with SQL queries. Question 3. How does GCP handle security compliance and certifications? Answer. Google Cloud Platform complies with major international and industry-specific standards such as ISO/IEC 27001, SOC 1, 2, 3, HIPAA, FedRAMP, and PCI DSS. GCP has rigorous security practices built into its infrastructure, including encryption at rest and in transit, identity and access control via IAM, and detailed audit logging. Compliance documentation and reports are accessible via the Compliance Resource Center in GCP. These certifications make GCP suitable for industries like finance, healthcare, and government, where data protection and privacy are legally mandated. Google also supports customer data protection agreements and meets GDPR and CCPA requirements for data residency and usage transparency. Question 4. What is the role of cloud load balancing in GCP? Answer. Cloud load balancing in GCP distributes user traffic across multiple back-end resources to ensure high availability and low latency. It supports both global and regional load balancing, including HTTPS, TCP SSL, and internal traffic types. Unlike traditional load balancers, it's software-defined and fully managed, offering auto-scaling, health checks, and seamless integration with Cloud CDN and Cloud Armor for security. Global HTTPS load balancing uses a single IP address for multi-region backend support. This helps applications scale seamlessly without downtime, and ensures users are routed to the nearest available backend instance with intelligent failover. Question 5. How does GCP VPC peering work and when should you use it? Answer. VPC peering in GCP allows private connectivity between two virtual private clouds, VPCs, within or across projects, without needing external IP addresses or VPN. It provides high throughput and low latency connections as traffic stays on Google's internal network. VPC peering is beneficial when you have multiple isolated environments, like dev, test, prod, that need controlled communication or when connecting shared service environments. However, peering is not transitive. VPC A peered with B and B with C doesn't mean A can talk to C. It also requires matching IP ranges and is useful for scalable, secure inter-service communication. Question 6. What is Cloud Pub Sub and when should you use it? Answer. Cloud Pub Sub is a fully managed messaging service in GCP that allows asynchronous communication between applications using a publisher-subscriber model. Publishers send messages to a topic, and subscribers receive those messages via subscriptions. It is ideal for decoupling systems and building event-driven architectures. Pub Sub supports real-time analytics, data ingestion pipelines, and multi-cloud communication. It's often used in microservices, IoT systems, and streaming data applications. With built-in scalability and support for message deduplication and dead letter policies, it ensures reliability even at large volumes. Its integration with Cloud Functions, Dataflow, and BigQuery makes it a powerful tool for building real-time and reactive systems. Question 7. What are GCP service accounts and how do they differ from user accounts? Answer. Service accounts in GCP are special Google accounts used by applications and virtual machines or VMs to authenticate and interact with GCP services securely. Unlike user accounts, which represent humans, service accounts are non-human identities tied to applications or workloads. Each service account can be granted roles via IAM policies, defining its permissions. They're commonly used for tasks like uploading files to cloud storage, accessing BigQuery data, or calling cloud APIs. Service accounts support key-based authentication, via JSON keys, and are integral for maintaining least privilege access in automated environments. Best practices include using short-lived credentials, rotation policies, and assigning minimal permissions. Question 8. How do you secure data in GCP at rest and in transit? Answer. GCP provides robust encryption mechanisms by default for securing data both at rest and in transit. At rest, data is encrypted using AES-256 encryption. GCP handles key management automatically, but users can also use customer-managed encryption keys or CMEK, or customer-supplied encryption keys or CSEK, for greater control. In transit, data is encrypted using TLS or transport layer security. GCP ensures that internal communications between data centers are also encrypted. Additional layers include VPC service controls, IAM policies, and Cloud Identity-Aware Proxy for application-level access. For high-security environments, tools like Cloud HSM or confidential VMs are available to provide even more secure data isolation. Question 9. What is Google Kubernetes Engine or GKE, and why is it preferred over self-managed Kubernetes? Answer. Google Kubernetes Engine or GKE is a managed Kubernetes service that automates deployment, scaling, and management of containerized applications. It reduces the operational overhead of maintaining Kubernetes clusters by handling upgrades, patching, node provisioning, and monitoring. GKE offers auto-scaling, auto-repair, built-in logging, and multi-zonal or regional clusters for high availability. GKE integrates seamlessly with GCP services like cloud monitoring, Pub Sub, and IAM, enhancing observability and security. Compared to self-managed Kubernetes, GKE offers better performance tuning, faster provisioning, and a stronger SLA or service level agreement. It's ideal for microservices, CI/CD, and production-grade workloads requiring minimal infrastructure management. Question 10. What are GCP labels and how are they used for resource management? Answer. Labels in GCP are key-value pairs attached to GCP resources, like compute engine instances, disks, or BigQuery datasets, to organize and manage resources at scale. They are crucial for resource grouping, billing analysis, automation, and policy enforcement. For example, you can label resources by environment, env equals prod, department, team equals analytics, or application, app equals CRM. Labels are especially helpful for cost attribution and filtering usage reports. They can also be used with tools like Terraform or Cloud Asset Inventory to automate audits or identify orphaned resources. Applying consistent labeling standards improves resource visibility, governance, and accountability in enterprise-scale cloud environments. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.